How do I use formulas? For arc length and sector area? To find radii, that's just plural radius, or central angles. So a central angle is angle from center of circle to edge, I guess. So a central angle so there's a circle, that's a common symbol for a circle, and a central angle goes to the edge. And so this theta is a central angle because it goes from the center of the circle, as you can see demonstrated here. So when we're talking about this, the central angle, it goes from the center. The edges are then radii, because anything that goes from the center of the circle to the outside is a radius. Here's the arc length, so the part of the circumference, and then the sector area is like the pi piece that we have. So we've talked about the formulas for the fraction of a circle. Remember that a circle is 360 degrees. So if I only want part of that, then I'm taking some angle that is part of the circle. Arc length, and you'll see it either as S, or I'm going to use AL a lot. The formula is that the arc length equals theta over 360 times 2 pi r. Now this part is just the circumference of a circle. So I just want the circumference of a circle, but I only want part of it. How much of a circle? Half of a circle, quarter circle, something like that. Area is either an A, or I'm going to call it sector area. You'll also see SA for surface area, but we're going to use it for sector area for this. And again, area is theta over 360, so some part of a circle, pi r squared. And that's the formula for the area of a circle. So we're looking at our examples, round to the nearest hundredth. That's 2 decimal places. And we're going to find theta, but then we're going to start working to find the radii, one of the radiuses, or the angle, given the information. So the first two are just simple plug-ins. So we're going to find theta when I have an R and a S. S stands for arc length. So S is theta over 360 times 2 pi r. So my arc length is 7.5 equals theta over 360 times 2 pi 5. So here's the 5, and the arc length goes here. So to start with, this is multiplied. So I'm going to divide by 2 pi 5. So that I get and then, so I have 7.5 divided by 2 pi 5 equals theta theta over 360. And then the opposite is to multiply by 360 so that I can isolate theta. So then you have theta equals 360 times 7.5 divided by 10 pi, which is 85.94. degrees. So it's the same formula we used for arc length. We're looking for the angle this time instead of just plugging it in to get the surface area. Excuse me. So this time I give you the area, and I'm looking for theta. So area is theta over 360 times pi r squared. 2 equals theta over 360 times pi 3 squared. Again, we're multiplying, so we're gonna divide. Oops. We're gonna divide by pi 3 squared. So that I have 2 over 9 pi equals theta over 360. And then we multiply both sides by 360. So 360 times 2 divided by 9 pi equals my theta, which is 25.46 degrees. So it's just the algebra and moving things to solve for a piece other than the way the formula is set up. This time we're going to solve for the radius. I'm going to give you the angle and the area. So it's the same formula. It's just how we plug things in. So I have the area. Area equals theta over 360 times pi r squared. Now remember that square roots undo squares. So r squared equals 25. Take the square root of both sides. That cancels, and I'm left with r is 5. So don't forget that that's how we take care of square roots, because I have to find r, but my equation is set up for r squared. So when we plug everything in, area is 31.5, theta is 55 over 360 times pi r squared. This is all multiply. So I can just divide 55 over 360 times pi and divide this 55 over 360 times pi so that I get that we get 65.6297. We put a couple extra things because we're going to take the square root, equals r squared. Because remember, this is here, and all of this goes here. So now to get rid of that, we take the square root of both sides, and I am left with r equals 8.1 inches. So that was just moving the formulas around. We didn't do anything extra. I just had to manipulate the formula to find a variable other than the way it was originally solved for. But these, I'm going to give you the arc length, and we're going to find the angle. So that means that that's the thing that I'm looking for. So my arc length is 11 over 6 pi. I know it's ugly, but when you do the calculator, you just put a fraction bar, and then you put another fraction on top, and possibly another fraction on the bottom, and then it's just about inputting things. So you just have to use the fraction bar a couple times. So PQ, that's my radius. So there's my radius. Theta is what I'm looking for, and there's my arc length. So I'm just going to plug it all into the formula. So S is theta over 360 times 2 pi r. 11 over 6 pi is theta over 360 times 2 pi times 3. Now remember, all of this is multiply. So then I have 11 over 6 pi divided by 2 pi 3 equals theta over 360, because we divided by 2 pi 3. Now I have to multiply by 360 on both sides so that my denominator is gone. So I multiply by 360 in the numerator. So this is where you would use the calculator. So I'd put a fraction button in, and then I'd do another fraction up top. So I'd put 11 over 6 pi times 360, and then I'd put 2 pi 3 in the denominator, in the calculator, and that gives me that theta equals 110 degrees. So you would put this entire phrase in the calculator all at once to get that theta is 110 degrees. Again, I'm just giving you the answer, I suppose, the way the formula is set up. I'm giving you one side, and you have to find a variable that's in the mix on the other side. So the angle, MLN, the angle is 120 degrees. The area is 27 pi. And I'm looking for the radius. I'm looking for this LM. So when I write the formula, area equals theta over 360 times pi r squared. My area is 27 pi. My theta is 120 divided by 360 times pi r squared. Remember that this is just all multiply. They're ugly numbers because they're fractions, but they're still just ugly numbers. So we're going to divide by 120 over 360 pi. 120 over 360 pi. Those cancel because pi over pi is 1, so I'm left with 27 over 120 over 360. So make sure that you do the big fraction and you put a small fraction in the bottom, and that equals r squared. When you do all that, that is 81 is r squared. Remember that square roots undo squares. Let's do the square root of both sides so that r is 9. All right, one more. So NO, my radius, is 3. The area is 9 over 5 pi, and I don't know my angle. So area is theta over 360 times pi r squared. 9 over 5 pi is the area. Make sure that when you put the pi that it's in the numerator or separate like that. Don't let it be in the denominator. Equals theta over 360 times pi 3 squared. Again, this is multiply. So I can just divide by that piece. Divide by pi 9. And those pi's cancel as well. So that I have 9 over 5 all over 9 equals theta over 360. And we're going to multiply by both sides by 360 to eliminate my denominator. So that I get that theta equals 72 degrees.